Okay, so we're going to continue with the functions today. So last time we're going to do 3.6 today. So we saw this last time, introduction to relations and functions. That was 3.5. Today we're talking about 3.6, which is function notation and linear functions. So review this, be aware of all the terms we learned last time. What's a relation, what's a function, how do you tell whether something is a function or not, from a table, from a set notation. You should also be able to tell from something like this or from graph. It's very easy also to see whether a graph is for a function or not. We also introduce the domain and range of a function. We're going to talk about that a little more today. Domain in set notation, range in set notation. So let's talk about the function itself. So far we've only seen not the function itself, but we just saw tables that are based on functions. We saw graphs that are based on functions. We saw set notations that are based on functions, but we didn't see the function itself, the formula, the expression. So today we're going to be discussing that in detail. So we're going to actually talk about functions themselves. So we're going to see the notation. We're going to see how a function looks like and what it's made of. So we're going to see basically the elements that make up a function. And okay, so let's call that the notation of a function. So usually we refer to a function as f of function, parentheses, x inside the parentheses. And then we have some y here or expression, or let's say some expression. Which is also equal to something, some value called y. That's the function notation. So this is f is the name of the function. We could give it any letter. Could be f, g, h, k. Normally something meaningful, but it has to be a letter like this. So this is basically the name of the function. This is some letter. Could be x, could be a, could be b, could be any letter basically. So that's the variable. And then the expression here, example, let's say x plus 2. An algebraic expression most of the time, okay? Could be power 1, 2, 3 of any degree. So basically it's an expression or a polynomial basically with some degree. Any degree could be from 0 to any other degree. 0 meaning the function has a number here, for example, 6 or 7. A constant, or x1, x2, x3, and so on. This is the value. We're going to see how to get that value later. So as an example, let's say f of x for example equals x plus 2. This is a function. So f is the name, x is a variable, and this is the expression. The expression here always involves the same variable. Or it might be just a constant without the x. You may see just 2 here or negative 3. But the same variable here, found in parentheses, is found also here in the expression. Okay, so basically what the function does, a function literally performs certain tasks that we assign it, for. So before we deal with functions themselves, so always think about the function as some machine. I always like to use the example of a blender. You know, a blender used to make smoothies and juices. So that's a function. Just like here, f is a function. this blender performs a function. So basically it takes something in and it gives us something out of that. The in is called the input. And what we get out of it is the output. Okay, so this is some function. In this case, a blender. Blender or a mixer. Okay, what does the blender take in as input? What do we put in it? What do we put in?
For example, we put the fresh fruits and output, we're gonna have like juice.
Exactly. So it takes some fruit and it gives us some output back. So the input is fruit. The output is some juice.
Juice, yeah.
Right? The juice based on this fruit. And to put this as a, let's call this B. So if you wanted to name this, we want to give this function a name, usually starts with a letter. The letter could be anything. So in this case, we're going to give it a more meaningful name. Let's call it B for blender. So this is the function here. Okay, so this takes, as an input, takes F or fruit, and it gives us juice back or J. So B for blender, F for fruit or the input, and as an output, we get J or the juice. That's how functions work. You plug in some X, you get some Y back. That's why last time we were talking about domain and range. This is what we input and this is what we get back. So this column is for the X or the input, and the other column is what we get back when we input this into that function. So domain and range. This is the domain and this is the range. In this case with the blender, the domain is the fruits. So the domain here for this function of a blender is fruits. So domain notation, we need name, colon, curly braces, and then could be, let's say, oranges, apples, okay, maybe bananas,
pineapple,
strawberries, and everything. So that's the domain, exactly. And the range is what you get back. This is usually the X, the range is what you get back. So for O, for orange, for oranges, you get orange juice, right?
Orange juice, apple juice, banana juice.
That's right. Apple juice and banana juice if there is something, basically a smoothie. Okay. So that's the concept of function. Something that does a certain function. We give it something, it gives us something back. That's all there is to it. This is an actual function, mechanical or electronic function that takes something in, blends it, and gives us something back. With math, it's the same thing. We make up functions, or we solve them, or we study them. So we take them to use them to perform a certain function. So we plug in some X, it runs through the function, some certain stuff happens to that number that we plug into the function, and then it gives us some output back. That value is some value Y. So let's have to actually work with the function here. So let's say that's basically how we get these tables or graphs we talked about, or these set notations. So we got them from a formula, from a function. They're not random, they're related. So we got them based on specific formulas. So let's say we want to make a table out of this. Please, I'm gonna mute you if I hear background noise from you. So let's say we want to get table out of this function, something like this we studied last time. So this first column is the X, what we plug into the function. The second column is the Y, or what we get back from that function. So let's say we want to plug maybe 1, maybe 0, maybe -2. So these are the inputs. We're going to run them through the function and see what we get back. So we're going to plug each one of these into here, and then we do some math and we get the value of y here. That operation is called evaluating functions. So evaluating is basically when you plug something into a function and simplify it. So let's say we're going to plug the 1 into the function. To do that, so this x is a variable means you could take this, 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 or other numbers. So it changes every time. So this time, instead of x, we're going to plug the 1. Okay, replace x with 1. And then in the expression, every x will also be replaced by 1. So we put 1 here, replace also this x by 1. You get something like this. Then you evaluate this, you get 3. So that's the value y that we talked about earlier. So when you plug something, something happens, you get a value back. You plug some fruit, something happens, some mixing goes on, then you get something back, in that case, a juice. So the 1 gives us 3. We say f of 1 is 3. So f of whatever is inside. Here we say f of x, but here we say f of 1. So here we say f of, that's how you read this notation here. So f of x equals or is 1, is y, depending on what the y is. That's how you read the expression. In this case, we have f of 1 is 3. So f of 1 is 3. And so on. Now we're going to do f of 0. So we evaluate this. Let's evaluate the other number, f of 0. Same thing. So we're going to plug the 0 into the function, replace all the x's with, that 0. So it's going to be f of 0. We're going to put 0 here, plus 2. So 0 plus 2 is 2. So f of 2 is, f of 0 is 2. So we're going to put 2 here. The last value, the last x that needs to be evaluated is -2. So we're going to take the -2, plug that into the function. So we're going to replace both of these with -2. Instead of x, we're going to put -2 plus this 2.
0, yeah?
That's right, will be 0. Okay, so that's the domain. And this is what we call the other column of y is called the range. Okay, and once we have that table, we could use it for different purposes. We can use it to graph the function, or you can use it to make sets. You can make set notation like this. We can use it to make basically anything we want, including graphs. So that's what we call evaluating a function. Please mute your mic. Marcetta, you have some noise, background noise. I don't know where it's coming from.
I'm sorry, I'm gonna mute.
Yeah, I don't know why it's always noisy at your end. So basically, that's how you evaluate a function. And now we're gonna see, again, like I said, once you make your table, you can do a lot of things with it, including graphing the function. So this is a function here that we made up as an example. We did some evaluations, domain range, like so. One of the uses of this table is graphing the function. So let's try to do that right now. So this was evaluating. Now we're going to see graphing. So graphing functions. So when we graph a function, depending on, so here we need a two-dimensional graph. We need an x-axis and a y-axis. Because basically, we have two columns, x and y. Each one of these represents an ordered pair, as we saw last time. Each one is a pair, which is basically a point on the graph. The x coordinate, the y coordinate. That's why we called it last time ordered pair. Each one of these represents X and Y. So we're gonna plot or plug all these. We have 3 points here. We have point, let's call this one point A, point B, and point C. So each pair, each point must have an X coordinate and a Y coordinate because the graph has 2 dimensions. We have the X coordinate and the Y coordinate. So first let's scale this. Let's put some numbers on this graph. So on this side we have positive numbers, 1, 2, 3, 4, and so on. On this side we have some negative numbers, -1, -2, -3, and so on. Same way with the y-axis. We have 1, 2, 3, 4, 5, 6, and so on. So these are positives. So up we have positives. Down here we have negatives. So below the 0 we have some negatives. That's how you make a graph. It's not hard to make. And the point here in the middle of, or the intersection of these 2 lines, the axes, is called the center or the origin of the graph. You see the center, both X and Y are 0. So it's 0, 0 here in the middle. That's basically the origin or the center of the graph. The numbers get positive here, negative, positive up, negative down. Okay, so now let's see how to graph. So this function, which we evaluated into this table, we're going to see how the graph looks like. I don't know if it's going to be like this, like this, like this, maybe like that. It's all different shapes. The shape depends on the function and determines specifically the power of the variables. So let's see how this is going to be. This is how this graph turns out. Could be any of these, but to find out, let's graph these points, and that should give us an idea or a sketch of the graph. So to graph the first point, 1, 3. So X is 1, Y is 3. So basically, you start from the X, always look for that point on the X-axis. Then you go to the Y, either up or down, depending on the sign of this. So start from 1, go up 3. 1 is here, go up 3, 1, 2, 3. That's the first point, A. Okay, that's our first point, A. Then to graph the second point, B, start from 0 on the X-axis, find 0 here, which we said happens to be right in the middle. So then start from here and go down, actually go up twice. Start from X0, which is in the middle, and go up twice. Vertically, okay, vertically on from the X0, and the point will be right here. That's point B. Okay, so the last point here, C, again, start from the X-axis, -2. Where do you find -2 this time on this axis? X -2, where do you find it on this axis?
To the left.
That's right, it's going to be negative, so it's going to be on the right, to the left of 0, so it's right over here. Where do you go from there? So this is X -2, the Y is 0, so where do you go from the X? Do we go up or down, or do we stay?
Stay on a line, goes towards the middle.
That's right. So look for the X, which is -2. Then you go up if this is positive. You go down if it's negative. If it's 0, you stay right here, right on the X. So in this case, we're going to stay right over here. That's point C. Look for the X, -2. Don't go anywhere from there because the Y is 0. What do you notice about these points? What kind of shape or graph are they making?
Line.
Looks like a straight line. That's right. All these points. Now what's left to do is just to join them with a line. Usually you would use a ruler. I believe I should have, yep, I found it. I have a line here. So That's the graph of this function. So this function here is basically just a graph that looks like this. So the graph of function f of x, x plus 2 is this red line. We got it through the table, so we made up some values of the x, some inputs, plugged them, we got some outputs. Each one of these rows makes an ordered pair, x coordinate, y coordinate. You plot those on the graph and you get the graph of the function. This is for this specific one. Other functions might look different depending on the expression here, depending on the variable. So this is basically a line. That's why we call this a linear function. Okay, that's why we call this a linear function, because the graph is a line. Specifically, what makes this a linear function is the power of the variable. If the power of the variable is 1, you know that's going to be a linear function, and you expect the graph to be a straight line, not any of these curly lines. Okay, so the power makes the function linear. So let's write that over here. Linear function because of its power. So next time you see this, you see the function, before you graph it, you already know it's going to be linear. If you end up with something that's not linear, let's say you get one point like this, another point like this, some point here, you know there's something wrong, because this doesn't look like a straight line, it looks like that. So you know something is wrong. You have to revise your signs as you plug here. You could easily make mistakes here, so make sure you revise your signs and you get everything right. That's basically how you evaluate any function. So when you mean evaluate, plug any values. These might be given to you, might be given a table. If you're not given a table, you can make up your own easily. Take a positive number, 0, and the negative numbers. Sometimes there are certain numbers you can't use here. We're going to talk about that when we talk in detail about the domain and range and functions. In another class, we can see that some certain numbers sometimes can't be used. We'll talk about this in detail another time. So for now, so that's a linear function, and this is the graph of that function. Does that make sense to everyone so far? Everybody in the room? Let me hear from all of you.
Yes.
Okay, everybody else?
Yes.
Okay, good. Everybody else, we have a lot of people in the
Yes.
room. Please let me know if you have any issues any moment. That's a linear function. Now, let's see another type of functions. So power was 1 here. Let's see what happens if we have power 2 here. So that would be another example here. Okay, graphing this function f of x, let's say is x to the second minus 3, for example. So this, again, this expression here is a polynomial. What is the degree of this polynomial?
So
2. All right, so the degree of the expression here is the degree of the polynomial of the function, and it also affects the shape of the graph, as we said earlier. So whenever you see power 1, if you see power 1, how's the line going to look like? How's the line? If the power is 1, we know the function will be linear, the graph will be straight line. If the power is 2, let's figure out together how this is going to look like. So first we need to evaluate some x values. So make a table, and it's some x values, some y values. Again, this is a domain, this is a range. So we're going to input maybe, let's take a few values here, maybe 1, 2, 0, probably -1, -2. So with the linear function, if the power is 1, it's enough. 2 points or 3 are enough. But anytime the power is higher than 1, the graph will most likely will be more complex than just a straight line. So I suggest you take as many points as you can. So take at least 5, sometimes more, depending on the function. That way, the more points you take, the clearer the sketch of the graph will look on your graph. So sometimes if you take just a few points, for example, you take just 3 points. So you don't know if the graph is going to go like this, or if it's going to go like that. So the more points you take, the clearer your graph will be. For example, this, or no, something like this. So the more points again, the better your graph will look like. So do not settle for just a couple of points. You may do that with linear functions, because if you see the power 1, so you know for a fact that that function is linear. So it's enough to take to find 2 points actually, and you graph that line based on 2 points, just 2 points like this, and you do the line through them. Other than that, you may need many points. So for this power 2 function, I'm going to take 5 points for now and see if we can see the shape of the graph. If not, we may add more points. As always, we're going to graph these first. So we're going to do evaluate this one, f of 1, f of. Again, we're going to take the 1, we're going to plug it into this function and replace all the x's with the 1. So it's going to be f of 1, 1 to the second. Okay, so just always you put some parentheses and then the power, okay? Put some parentheses for the x first and then plug the value inside of that. Then evaluate 1 to the second is 1 minus 3, that's negative 2. So f of 1 is negative 2. The input, the output. Same way we will do f of 2. So we're going to plug 2 here and here. It's going to be f of 2. Again, it's very important that you put some parentheses first for the x, the power. Then inside those parentheses, you put whatever value of x. Could be 1, could be negative 1, negative 2, whatever it is. It's very important to put the parentheses. So we're going to put this time 2. Then complete the rest of the expression, n minus 3. This will be 1. F of 0. If you plug 0 here, this cancels out. What's left? What is f of 0? You plug 0 here, this goes away. When you plug 0 into x, it goes away. What is left?
Negative 3.
That's right, just negative 3. It's very easy to plug the zeros because all the terms with x cancel out. You're left only with the constants, the number that doesn't have x. F of negative 1. I'm going to take negative 1, plug it into the function, so it's going to be f negative 1. Again, you need parentheses. If you don't put parentheses, it won't be the right thing. So negative 3. And then whatever the x might be, in this case is negative 1. So negative 1 to the second is, what's negative 1 to the second?
Positive 1.
It is positive 1. That's right, because negative 1 to the second is negative 1 times negative 1, which is positive 1. If we didn't put the parentheses, it will not be the same thing. It will be negative 1 to the second, which, as we saw before with the rules of exponents, this is different than this. This negative stays here, and you have 1 to the second. 1 times 1 is 1. So these are not the same. That's why I said you have to put those parentheses. Okay, put the parentheses around instead of the x first, then plug the value of the x inside, because these two are not the same. So this will be 1 minus 3, which is negative 2. Finally, we need to plug the negative 2. So f of negative 2. Again, we have an x here, so put some parentheses for that x. The power minus 3. Then whatever the x is, whatever you put here should go inside here as well. This will be negative 2 to the second, which is negative 2 times negative 2, that's 4. Take away 3 will be 1. This looks pretty good so far, 5 points. Should give us an idea how the graph looks like. So this is what we mean by evaluate. You make a table. You might be given a table. If you don't have one, feel free to make one like this. Usually take small numbers, some positives, some negatives, and 0. If it's allowed. If 0 is allowed, sometimes it's not allowed. We'll see when next time. All right, so all these are points, A, B, C, D. Is what we call order pairs. 1, 2, 1, 2, 3, 4, 5. Again, I'm going to need a graph like this one. Feel free to use graph in paper. You can print it out easily on Google. Just type graph in paper and print it out. Or you can make a graph. It doesn't take long to make one. It's not that hard. I do have some tools here, so I could use them. So I'm going to make a graph like this. You can feel free to use your rulers or your graphing paper. Now I'm going to put some points here. As always, this is the x-axis, the y-axis. They're perpendicular. That means they make a 90-degree angle here, perpendicular. This is the scale of this. So it's got to be the same distance in all these units. Between any 2 points, it got to be the exact same distance. Otherwise, your graph would be disproportionate and things wouldn't look right. So positive numbers here. And now we're going to plot our points. So we have 5 of them. Start with this one, 1, -2. Where do you start? Where do you go? To plot A. Everybody?
X.
Where do you start exactly, and where do you go?
Start at 1.
On what axis?
The
X.
X.
Okay, this is x-axis. So 1 would be here. And where do you go from there?
To -2 on the
-2.
y-axis.
Does that mean you go up or down?
Down.
Go down to negative. Start from here. That's right. We're going to go down to -2, which is here. Start from here. Go down. So that's our first point. Then, how do you plot the next point?
on the
2 on the X.
X-axis. X.
On the x,
And then 1 on the Y going up.
go up once, right? Go up right here, across from 1, which is here. This is the second point. Let me use a different color. So, what else?
You start
Whoever has kids in the background, please mute yourself. Next point is 0, -3. So where do you start? 0. Where do you find 0 again?
Into center.
That's right, the center. And where do you go from here?
Go down to -3.
That's right, go down 3 units. 1, 2, 3, because the y is -3. So start from 0, go down to -3. 1, 2, and 3. So this was A. This was B. This is our point C. Then we have -1, -2. Start from -1, which will be here on the left side. And where do you go from there?
-2 on the y-axis.
That's right. We're gonna start from here, go down twice. Gonna go down right over here. Let me put this 2. We're gonna start from -1 and go down to -2. Start from -1, -2 is here. Okay, so this is -2 here. Final point, -2 to 1. Where do you find -2 again? What axis?
On the X.
X-axis, which will be right
On the
here.
left.
This is -2. Okay, so we go from -2 to where?
1 on the y, so up 1.
That's right. So from here, we go up once. From here, go up once, right across from 1. Do you guys see the shape of the graph now?
Yeah, a v.
Not necessarily a V, but close. It's more of a curve. Okay, more like a U-shaped graph or a curve. Not exactly a V. That's why I said earlier, take as many points as possible. So with this kind of function, when the power is 2, remember that this graph will look like this. It's like a U-shaped graph. It has a specific name. Can someone, some very smart person in the room, tell us what is the name of a graph that looks like this? They have a specific name in addition to the U-shaped graph, whatever, curved graph. What do you think we call that? So when you join these points, make sure again, you curve things out.
Crescent.
You don't want to make it a V. Make sure it goes through all the points. It can be a little hard to do. Something like this, basically. And the graph keeps going up and up. Okay, because it only took few points. You could take, I don't know, dozens of points here. The more points you take, the more you'll see here. But these arrows indicate that the graph keeps going up infinitely because there are many points we can plug. So it's a U-shaped graph. Anybody figure out the name? Starts with a P. P, then an A, then R. Say that again?
Vertical, something like that?
No, it starts with a P. P, A, R.
Parabola.
Exactly. Very good. Parabola. So this type of graph is called a parabola. So parabola. Okay, it's facing like that. It's shaped like this. Again, when you draw it, make sure it's not a V. It's a curve. It's a curve, so make sure you draw that carefully, slowly. So that's basically any second degree function. So any first degree function, the graph is aligned. Any second degree from now on, remember, it's going to be like this. It has to look like this. If it doesn't look like this, it means you did something wrong. You have to repeat it. The only difference you may see is sometimes the graph may be facing up, or it may be facing down, depending on the sign of this. If this is positive, it was facing up. If you had a negative here, and be careful when you plug with the parentheses and everything, your graph will look like this, would be facing downwards. Does that make sense?
Yes.
Okay, so if this is positive, the term with the second power is positive, expect your graph to be facing up. It has to be a parabola. It doesn't always have to be exactly here. It could be over here, could be here, could be anywhere on this graph, depending on these numbers here. That's what affects the transition or translation of the graph on the X and the Y axis. Remember, if you have a negative here, plug everything correctly, your graph should be facing downwards instead of upwards. Okay, so this is what we call a second degree. Function, or a quadratic function. You can also call it quadratic. Quadratic because of the power 2. This power is basically what affects the type of the function, the name, the domain, the range. If you have 1 here, it's linear. It's going to be a straight line. If it's 2, it's going to be a quadratic function. To give you a few more briefly, if the power is 3, if you have, for example, x to the third, I'll give you a quick sketch of the graph. You can play with it yourself later. You can do a table like this, and you see that it looks like this. So for this kind of function, third degree function like that, the graph will look like this. You can experiment with it later. Take a bunch of points here, take maybe 10, find y and plug them. You'll see that the function will look like this. This is a cubic function or a third degree function. We also have this one, 1 over x. But the graph of this function is interesting. It's gonna look like this. It has 2 parts to it. So that looks like that. I believe this is called a hyperbola. Hyperbola, if I remember well. So this is a hyperbola. This is a parabola. And again, you can easily find these yourself. Just again, take these functions, make a large table with 10, at least 10 inputs. You get some outputs and plug your numbers. You could have fun with it if you want, and figure out that it looks like this. It's just good to have an idea of how the graph looks like. That way, you already know how it's going to look like. And if your graph doesn't end up like this, you know that you made a mistake. You can correct it. So at least remember these 4. So if you have first degree, the graph has to be linear. Second degree, the graph is a parabola, up or down. If it's third degree, it has to look like this. It doesn't exactly go through this every time. It could be shifted to left, right, up and down, depending if you add 2 here, if you multiply by 3 here or something. Same thing with this one. It could be shifted anywhere based on maybe if you have 2x here or -3 up or something. And also here, depending on these numbers here. And then there might be a number here, for example, 3 times x to the second, that causes the graphs to shift up, down, right, left. But you can easily graph them using a table like this. Okay, everybody, makes sense?
Yeah.
Have you had enough functions? Can you still function?
Yes.
Okay, very good. So functions are not that complex if you take them, one step at a time. One concept at a time. It's a lot of information, but it's not complex information. That's why I broke it down into 2 classes. This one broke it down to 2 classes. There's more to come. Probably gonna have at least 2 more classes on functions. Every time we introduce new topic, a new concept. Let's see. So now, basically we learn how to, the notation of the function, we learn how to evaluate, how to graph. To complete a table, now we're gonna learn another thing. We're gonna see how to actually go backwards. We can make a table based on a graph. We can take a table of a function. We can go backwards and make. So let's start, say, graphs. Example here. Sometimes you might be given, let's say, this, maybe that. Maybe some points here. For example, this one, maybe this one. Call this 1, this is probably 2. This is about 1, maybe 2. This is probably 3. So if you look at it this way, so now instead of making a table or a graph, we can make a graph, can make a table from a graph. So we go in the other way. Let me close that window. So you can start actually with a graph and make the table instead of backwards. Here we made the table first, we changed it into a graph. So inputs and outputs, so X, Y. So let's try to put these on this table. What is f of 1? What is f of 1? If the x is 1, what is the y of this point?
0.
Exactly. So you drop it on the y-axis. This is the y-axis. This is the x. So this is the x, is 1. So the y, you drop it horizontally on the y, you get 0. So we say 1 and 0. What is f of...
Shouldn't it be -1?
Exactly. Yes. That's right. Very good. Now, what is f of, let's say, 2? x2, what's the y? So this is the x. Always locate this on the x-axis.
3.
So that's what the notation is. That's right. The notation says x here, f of x equals y. So the number inside the parentheses is the x. So you look for that on this x-axis. You look for the 2 on the x-axis, which is here. And then from there, you want to find the y. So you go, so that's the point here. So 2 on the graph is here. So the y must be this. So you can do the little dashed line like this. Okay, so this point of the graph, the x is 2. So f of 2 is 3. F of 2 is 3. Sometimes you may go backwards. Let's say it may give you this. This is the y, so we know that f of x is y. If you have this one in parentheses, so you got to look for that on the x-axis. Find it first, then find the y. But if you have this value here, that would be the y. You need to find the other one. So let's say if I said f of x is 2, this 2 here. It's a y because it's on the y-axis, okay? Because this number here is the x. The number on the other side is the y, or the value. So if y is 2, what is the x on this graph? The y is the y-axis, and this is the y. If the y is 2, what is the x of this point?
0.
That's right. So this point, it's the y, because we put it here on the y. So this one is missing. So you look for this. This is a y. You look for it on this one, not this one. You look for it on the x-axis if you have a number inside the parentheses. So the number inside the parentheses is always the x. So if you have this one, find it here before you find the y. So for this one, if you're given the y, which is here, you find the y first, and then for this point on this graph, the x is here, is 0. Let's do another example. Let me see. Let's take this point. Now we'll call this probably -3. And let's call this -2. So now for this one, let's say you have the y. So let's say for this y, so we have the y, but we need the x. So you find the y first on this axis. For this one, what is the x? For this graph, if y is -2, if y is -2, what's the x?
0.
Not 0. So basically you want to go to the graph. So
-3.
That's right. So if you have the y, you got to drop that on the graph. This is our graph. So here, the y is -2. So you have to go to find the x, you drop it on the x-axis. So each point again has 2 coordinates, the x and the y. So this will be -3. So basically that's how you take a graph and make it a table. Not always that you have a table and make it a graph, but you can go backwards. Okay, did this part make sense, everybody? You can fill up, you can make a table based on a graph like this. Let's do another one quickly like this. Say 2 here, maybe 3, -3, maybe just -2, and 2. So let's complete a table based on this graph. So we have this point here on the graph, we have another point, and we have this point. So you're gonna need 2 columns, X and Y. Let's fill this up. The first, so these are the X's. So what are the X's on this graph? We have this one. What's the X here?
-2.
-2. Okay, if X is -2, what is the Y of this point? Is this point, right? 3.
+3. Yeah.
+3. Okay. What about this point here? What's the X?
2.
0.
No, the X.
0.
X is 0. That's right. And what is, so the X is 0. What about the Y of this point?
2.
Still, it's right here, 2. Now, let me give you another one. Let's say if Y, for this one here, X, for this point, what's the X?
2,
2 on the Y
3.
is also 3. Okay, so you can easily go back and forth between these. If you have a table, you can make it a graph. If you have a graph, you can make a table. If you have a function, you can make both. Function is basically the origin or the actual formula or expression that we need. So if you have it, then you can use it to do anything, to make tables, graph, and everything else. And that's basically how you graph your functions. You can graph any degree of, in a function of any degree using the same way. From 1, 2, 3, 5, anywhere, any value. Just make a table, plug some values. Some values can be restricted sometimes. We're going to talk about those next time. Other than that, you can plug a bunch of points and then sketch your graph. So you need to know your signs, of course. Be careful as you plug your numbers, because one sign wrong could put the point in the wrong place, and the graph wouldn't look right. I believe that's it for today. Do you guys get everything about this class today?
Yes.
Yes.
Did anybody have any questions, any issues? Talking to all of you. Let me hear from all of you here, please.
No questions.
Mm-hmm.
No questions.
All right. So you can rewatch this. I'm going to post this soon to Blackboard. You do need to rewatch it. I understand there was some new terms. It was quite a few things we talked about. So if you rewatch it, you will understand this even more. Next class we're going to have another. I'm going to talk about domain and range in detail and see. We're going to see when and where for certain functions we're not allowed to use certain values. We can't plug some values. It's like here, random, I don't know if it's a scientific analogy, but something you can't plug into a blender. Give me an object that you can't plug. Pretty much anything other than fruits and vegetables and maybe nuts can't be plugged here, right? For example, if you're gonna plug, I don't know, if you're gonna input rocks, you're just gonna destroy your blender. It's not gonna work. It's probably not gonna get you anything other than a damaged thing. So some items are restricted. For example, when you buy a machine or a blender or a microwave, it will say in the catalog, or it will say something like, or the user manual, it will say something like, can't use this, can't plug that. Same thing with functions. Same thing with functions. There are certain things we can't plug, we can't use. We're going to talk about that in detail in our next class. That's again an extension to the domain and range. So this is pretty much it for today. Rewatch the lecture, watch this video, and things will make more sense. The more you watch it, the better you understand this, you know, even better, like I said.